Tonight is October the 4th, 2014, and I picked up for repair from a gentleman in Las Cruces, New Mexico, this Harman Kardon A300. I'm not personally familiar with this unit as something that I've ever owned or used, but they seem to be pretty popular. It runs, has a solid state power supply. These tubes have a number of 7408, which are 6 V6s. There's a bunch of 12AX7s, 12U7 driver, output transformers. All that was really wrong with this one, well, this right here was busted. That's a little series capacitor, part of the power supply. You can see I drilled it out and put a new, new one of these thingies in there. But overall, it's pretty good. It doesn't have a whole lot on the front. It has an aux and a tuner, which is the same high-level stuff, and then a high-level phono, and then a phono and low and tape low. So phono low, phono high, tuner and aux. Very simple. So we're going to check it out tonight. I'll compare it to the specs. I got the schematic off the internet. I got to show you something here that's truly novel. Look, see how you can't see this one up here, but see how the cathodes are tied together. They go to a capacitor to ground, bypass capacitor, cathode bypass, and look at the cathode resistor. It's V1 and V2. It's I guess this is V1 and V2. I guess that's how they get DC on their preamp tubes, and they also eliminate a resistor. I have never seen that. I noticed when I was looking at it underneath that the cathode wire went over to one of the 12EX7s. I said, I'm going to have to look that up. But anyway, it's pretty clean. Got our own turntable here. I'm just going to feed it into the tape aux input and feed both channels at once, running it on 120 volts input. Set it right on. If you've seen any of my videos, you know I run them into these precision dummy loads up here. They're 1%ers, and we'll be looking at it over here on the distortion right here. Of course, nothing's happening right now, so you can ignore that. THD, I'll program this one, clear 19.008 special. That'll read direct power. This is voltage. You can square that and divide it by 8 and you'll get that number, but you don't have to do that, and this will be THD. Frequency down here will be read out, and then we'll always look at the waveform on the oscilloscope. So let me get it hooked up, turned up and adjusted so you can look at it and we'll see. We'll run THD and signal to noise ratio on it. That's probably about all we'll do, and see how it performs. Okay, I've got it pretty well balanced. The balance control's a little off to the right. No big deal. This blend control's pretty interesting if you want to look at the schematic of it. I'm not going to go over it right now, but what I've got it adjusted for is 10 watts at a 0.5% distortion. Both channels are balanced. That's the left channel. That's the right channel. Play it back to left. Here's the oscilloscope. Get that wire out of the way. That's what that looks like. Left channel, right channel. Go back to left. They both perform pretty much the same. Now, if I run the power up, they rate it at 12 watts. If I run it up to 12 watts, very carefully here. Let's get it there. 12 watts, okay. That looks okay. Distortion's up to 17.9%. The channel 17, same thing. 12.33. Pretty horrible, 12 watts. So if we adjust this and run it back down to where we lose our clipping and things don't get out of whack, about right there, we got 10 good watts. That's at 4 point something percent distortion. That's at about a kilohertz. That's what it looks like. So that's what it does. It's really a good 10 watt amplifier. It may sound marvelous. I don't know. I'll probably never listen to it. But it's actually quite clean. Let's see if I can set it up on its side while it's on, of course. Nice and clean under there. It's all original. I don't think anybody's messed with it. Probably, you know, they got tired of it. They needed a new one. They set it aside. Of course, the controls, all these little switches here were just terribly dirty. But cleaned all those up. It's got those nice Black Beauty sprayed caps in there, so it's actually pretty good. Okay, so that's that. Let me do just a little bit of rewiring. We'll run a signal to noise ratio on it. Okay, set this thing up for signal to noise ratio. This HP8903 is a marvelous device. Love this thing. To run signal to noise, you just say the second one, signal to noise, and then you have to set the frequency. Frequency 1 kilohertz, amplitude 4 volts, and then we'll adjust it to wherever we want it. Okay, there it is running. We'll run it up a little higher than that. Yeah, see, it's starting to, doesn't look too good up there, so let's get it back down in the nice clean range. That's it right there. That looks good. Signal to noise at a kilohertz. 65 dB. Right there. 65.5 dB. Not bad. Really not bad. By the way, this thing does S to N is it puts a kilohertz on at whatever level you want it. You adjust it to, measures the output, shuts it off, and measures it again and compares the two. So there it is. There's the award series Harman Kardon A300, still alive and kicking, and not too bad. I bet it sounds pretty good on a pair of real high efficiency speakers like some Klipschorns or something like that. Anyway, I haven't done any audio in quite a while. I've been into my RF too much, but and I quit doing audio amplifiers and musical amplifiers as a whole because it was just taking up all of my time. I got a tiny little shop. I was making no money, and you know, I had other things to do. But I still do this occasionally, and this is one I hope you enjoy.